Here is the one more important topic, that is first shifting theorem. It states that if Laplace transform of f of t is equals to f bar of s, then Laplace transform of e power a t into f of t is equals to f bar of s minus a. So this condition, when we find the Laplace transform of e power a t into f of t, we get the f bar of s minus a. So that is nothing but Laplace transform of f of t. So here is a proof, and that equals to integration from 0 to infinity e power minus s into t into f of t into dt is equals to f bar of s. By the Laplace theorem we have this. So in the if we multiply with e power a t, that is Laplace transform of e power a t into f of t, that equals to this equation is multiplied with one more extra function, that is e power a t. When when only f of t is there, we get e power minus s into t into f of t dt. But if e power a t is multiplied with f of t, then we get here integration of 0 to infinity e power minus s into t into e power a t into f of t into dt. So we got the extra term e power a t. It is multiplied with both of the equations. So because we need the we have to prove that Laplace transform of e power a into t into f of t is equals to f bar of s minus a. So here when bases are multiplying and they are same, so powers will be added here. So minus st plus at. From this both we can take t common. So minus, and minus also we can take common. So minus of s minus a into t, minus s into t, that is minus st, minus into minus plus at. So we got this. So we can write it as integration from 0 to infinity e power minus of s minus a into t into f of t dt. So that equals to f bar of s minus a. Here when we do this, in the place of before t we have the minuses. If we exclude the minus, we have only s. So we get the f bar of s. Similarly here in the place of s we have the s minus a. So we get it as f bar of s minus a. So this is total equal to Laplace transform of e power a into t f of t. So therefore Laplace transform of e power a into f of t is equals to Laplace transform of f of t changes s to s minus a. So when we find the Laplace of this, that equals to the Laplace transform of f of t. But here s is changing from s to s minus a. So this whole equation can be written as Laplace transform of f of t and changes s to s minus a. Let's see a few of the formula here. Laplace transform of e power a into t power n. For example, here f of t is equals to t power n, and this is multiplied with e power t. So here the changes from s to s minus a, where a is nothing but the t coefficient here, the constant t. So that equals to Laplace transform of f of t. F of t nothing but t power n, and changes from s to s minus a. So that equals to Laplace transform of t power n is n factorial by s power n plus 1, and this also changes from s to s minus a. So changing s to s minus a nothing but we have to replace s by s minus a. So here we have the s, we have to replace this s by the s minus a. So that is n factorial by s minus a whole power n plus 1. So in this way we transform this first shifting theorem. Here Laplace transform of e power a into t sin bt. So here f of t is equals to sin bt. That is equals to Laplace transform of sin bt is changes from s to s minus a. So here Laplace transform of s into bt nothing but b by s square plus b square, and this changes from s to s minus a. So in the place of s we have to substitute the s minus a. So b by s minus a whole square plus b square. And similarly Laplace transform of e power a t into cos bt. So here f of t is equals to cos bt. That equals to Laplace transform of cos bt changes from s to s minus a. but Laplace transform of cos bt nothing but s by s square plus b square, and this changes from s to s minus a. So in the place of s, substitute s minus a. So we get s minus a by s minus a whole square plus b square. Let's see few of the problems on this. First problem, find the Laplace transform of e power minus t cos 2t. So Laplace transform of e power minus t cos 2t. So here f of t nothing but cos 2t. The same first shifting theorem we have to apply here. You can see one thing here. E power minus t is multiplied with cos 2t. If we get a plus or and minus sign, we have to separate it the Laplace transform to each of the term, and there we cannot use the first shifting theorem. So when e power minus at into f of t, if it is in that form, then only we can apply the first shifting theorem. So here this can be written as Laplace transform of cos 2t changes from s to s plus 1. So because we know that it changes from s to s minus a, but here a value is minus 1. So a value is equals to minus 1. So when you substitute this minus 1 here, that is s minus of minus 1, minus into minus is plus, so we get s plus 1. So this changes from s to s plus 1. So this s minus a depends on the power of the e. So that equals to cos 2t formula, that is s by s square plus a square cos 80, Laplace transform of cos 80. But here in the place of a we have 2, that is 2 by 2 x square plus 2 square changes from s to s plus 1. So here in the place of s we have to substitute the s plus 1, that is s plus 1 by s plus 1 whole square plus 2 square is 4. So that equals to s plus 1 by s plus 1 whole square is s square plus 1 square plus 2s plus 4. That is s plus 1 by s square plus 2s, 4 plus 1 is 5. So this is the final transformation of the given equation. So in this way we do the first shifting. Let's see few more problems on this. Here is another problem on the first shifting theorem. Find the Laplace transform of e power minus 3 into t of 2 cos phi t minus 3 sin phi t. So here e power minus 3 is multiplying with this whole function. So we can apply the first shifting theorem. So first find out the Laplace transform of this inside function, that is Laplace transform of 2 cos phi t minus 3 into sin phi t. So Laplace transform of 2 cos phi t minus 3 sin phi t. So we can apply the Laplace transform to each of the terms separately. 2 is a constant, so write outside. So 2 into Laplace transform of cos phi t minus 3 is also constant here. So 3 into Laplace transform of sin phi t. So 2 into Laplace transform of cos at is s by s square plus a square. Here a is 5. So we get s by s square plus 5 square. Minus 3 into Laplace transform of sin at is a by s square plus a square. So that is 5 by s square plus 5 square. So here 2 into s by s square plus 5 square is 25 minus 5 3s are 15 by s square plus 5 square is 25. So here the numerator we take LCM, that equals to 2s minus 15 by s square plus 25 is the Laplace transform of 2 cos phi t minus 3 sin phi t. Now we have to find out the Laplace transform of the whole function. So Laplace transform of e power minus 3t of 2 cos phi t minus 3 sin phi t, that equals to we can write it as Laplace transform of 2 cos phi t minus 3 sin phi t and changes from s to s plus 3. So here it is changes from s to s minus a, but here a value is minus 3. When you substitute this in the place of a, so s minus of minus 3, that is equals to s plus 3. So it changes from s to s plus 3. Now Laplace transform of 2 cos phi t minus 3 sin phi t, we got it as 2s minus 15 by s square plus 25, and this changes from s to s plus 3. So in the place of s, substitute s plus 3. So we get s of s plus 3 minus 15 by s plus 3 whole square plus 25. So 2 into s 2s plus 2 into 3 6 minus 15 by s plus 3 whole square, a plus b whole square formula I had to use, s square plus 3 square plus 2 into 3 into s plus 25, that equals to 2s minus 15 plus 6 is minus 9 divided by s square plus 6x and 9 plus 25 is 34. So in this way we have to solve the force shifting theorem.